Hello. In today's lesson, lesson 3.2, we're going to be talking about identifying opposites and the absolute value of rational numbers. So, how do we identify opposites and absolute value of rational numbers? So, remember that all rational numbers can be represented as points on a number line. Positive rational numbers are greater than 0, and they are located to the right of 0. Negative rational numbers are less than 0, and they're located to the left of 0 on a number line. Also remember from our last lesson that rational numbers include all integers and all whole numbers. All right, so let's look at this example. Water levels with respect to sea level has an elevation of 0, may be measured at beach tidal basins. Water levels below sea level are represented by negative numbers. Okay, and this table here shows water level at tidal basin at different times during a day. And so we need to take these levels and graph them on the number line. All right, so at 4 a.m., it's 3.5. So that's going to be to the right of 0. And we know that it's not 3, it's not 4, it's exactly in between, right? So 3.5. I'm going to go ahead and mark that as point A. At 8 a.m., point B is at 2.5. So again, it's in between 2 and 3. C, it's negative a half. So it's going to be to the left of 0, and it hasn't reached 1 yet, so it's going to be in between 0 and 1. D, negative 2.5, will be in between negative 2 and negative 3. And E is in between 0 and 1. All right, how do we know where to graph negative 1/2? Well, it's between 0 and negative 1. At what time or times is the level closest to sea level? And how do you know? Well, sea level is 0, so which times is it closest to that? Well, there's 2 times, right? C and E. So at noon and at 8 p.m. Which point is located between negative 3 and negative 2? So we go to the negative side. What's in between 2 and 3? Point D. And which point is the same distance from 0 as D? So negative 2.5, so we need 2.5 on to the right of 0, and that's point B. All right, how would you graph negative 2 and 25 hundredths? Would it be to the left or right of point D? All right, so negative 2.25. So it would be negative 2.25 is less than 2.5, right? Another way of saying 2 and 25 hundredths is 2 and 1/4. So a fourth is less than a half. So it would be to the right of point D. It would be halfway, or it would be between negative 2 and negative 2.5. Okay, let's look at page 54. All right, rational numbers and opposites on a number line. Okay, so we can find the opposites of rational numbers that are not integers the same way you found the opposites of integers. Two rational numbers are opposites if they are the same distance from 0, but on different sides of 0. So, for instance, 2 and 3/4 is the same distance from 0 as negative 2 and 3/4. On June 24th, 1997, the New York Stock Exchange priced the value of share of stock in eighths, such as 27 and 1/8 or 41 and 3/4. The change in value of a share of stock from day to day was also represented in eighths as a positive or negative number. All right, so the table shows the change in value of a stock over 2 days. Graph the change in stock value for Wednesday and its opposite on a number line. So the change in value was 1 and 5/8 on Tuesday, and Wednesday was negative 4 and 1/4. So how would we graph that? Well, step one, graph the change in stock value for Wednesday on the number line. So negative 4 and 1/4. And then graph the opposite of negative 4 and 1/4, which would be 4 and 1/4 in the positive side. And so the opposite of the change in value for Wednesday is 4 and 1/4. So we graph the stock value for Wednesday and its opposite. Simple as that. Okay. So what are the opposites of 7? Well, what number is the same distance from 0, but on the opposite side of 0? Negative 7. What would be the same distance as negative 3.5? Positive 3.5. 2 and 25 hundredths? Negative 2 and 25 hundredths. 9 and 1/3? Negative 9 and 1/3. Okay. Right. Number 55, page 55. Absolute values of rational numbers. Okay, that's basically what we've been talking about here. So we can find the absolute value of a rational number that is not an integer the same way you found the absolute value of an integer. The absolute value of a rational number is the number's distance from 0 on the number line. Simple as that. So the table shows the average low temperatures in January in one location during a 5-year span. Find the absolute value of the average January low temperature in 2009. So we look at 2009 and we see it's negative 5 and 4/10. Its absolute value would be the same distance from 0. So 5 and 4/10. And so we would write that as the absolute value of negative 5 and 4/10 is 5 and 4/10. All right, what is the absolute value of the average January low temperature in 2011? And how do you know? In 2011, it's 3.8. Okay, so 3.8 would be right about there, right? So the absolute value of 3.8, again, is just a distance away from 0. So the absolute value of 3.8 is 3.8. 3.8 is non-negative. So the absolute value is simply that number. Okay, because we always represent absolute value as a positive value. All right, so number 4. Graph each number on the number line, then use the number line to find each absolute value. So find negative 4.5. So 1, 2, 3, 4, exactly in between 4 and 5. So the absolute value of negative 4.5, what is its distance from 0? 4.5. 1.5. So 1 and 2, it's exactly in the middle of 1 and 2. And since it's already non-negative, we just write its value, its distance from 0 as 1.5. 4. 4 is non-negative. The absolute value of 4 is 4. Number 7, negative 3 1/4. 1, 2, 3. So negative 3 1/4, its distance from 0 is 3 1/4. Page 56, number 1. Graph each number and its opposite on a number line. Okay, so negative 2.8. 1, 2, 3, 4, 5. So 1, 2 is going to be closer to 3. And then we'd put the same thing on that side. 4.3, or 4 3/10. 1, 2, 3. 1, 2, 3, 4 3/10. So it's going to be shy of 4.5. And the same thing on the opposite side. Negative 3 4/5. 1, 2, 3. It's almost 4, or negative 4. And the same thing on the opposite side. 1 1/3. 1 1/3. Negative 1 1/3. All right, find the opposite of each number. So 3 7/8 is positive. Its opposite would be the same number, but to the right, to the left of 0. Negative 7 5/12. Its opposite would be in the positive direction. 0 is 0. The opposite of 0 is 0. 4.2. Negative 4.2. 12.1. Negative 12.1. 2 6/10. Negative 2 6/10. Explain why 2 15/100 and negative 2 15/100 are opposite. Well, they're the same distance from 0, just on opposite sides of the number, the opposite sides of 0. Okay, find the absolute value of each number. Again, remember, absolute value simply is the distance away from 0, represented as a positive number. So the absolute value of negative 4 2/11 is 4 2/11. Absolute value of 0 is 0. The absolute value of negative 6 3/5 is 6 3/5. The absolute value of negative 2 12/100 is 2 12/100. And the absolute value of 8 2/10 is 8 2/10. All right, use the absolute value for 18. Use the absolute value to write a definition of the opposite of a non-zero rational number and give an example. So the opposite of a non-zero rational number is a number that has the same absolute value but a different sign. All right, so let's write that down. So the opposite So the opposite of a non-zero rational number is a number that has the same absolute value but a different sign. For example, negative 2. Okay, so negative 2 is the opposite of 2 because they both have an absolute value of 2. They have a distance of 2 from 0, but they're opposite signs, right? Negative and a positive. Move on to page 57. Number 19. A store's balance sheet represents the amounts customers owe as negative numbers and credits to customers as positive numbers. All right, so Girardi, he owes $85.23. Lewis has a credit of $20.44. Stein has a debt of $116.33. Juan has a credit of $13.50. And Wenner has a debt of negative $9.85. So write the opposite of each customer's balance. Okay. So again, we're writing the same number basically with just different signs for its opposite. And Wenner, 985. All right, 19b. Mr. Juan wants to use his credit to pay off the full amount that another customer owes. Which customer's balance does Mr. Juan have enough money to pay off? He wants to use his credit, so he has a credit of $13.50. The only one that has an absolute value less than $13.50 is Wenner's. All right, which customer's balance would be farthest from zero on a number line? Well, we're basically looking at which number has the largest absolute value. 85 is bigger than 20, but 116 is larger than 85. So Stein's. Stein's balance, if you take the absolute value of negative 116.33, it's the largest value in the set. All right, number 20. So Trina went scuba diving and reached an elevation of negative 85 and 6/10 meters, which is below sea level. Jesse went hang gliding and reached an altitude of 87 and 9/10 meters, which is above sea level. Who is closer to the surface of the ocean? Trina is. Because the absolute value is closer to zero. Trina wants to hang glide at the same number of meters above sea level as she scuba dived below sea level. Will she fly higher than Jesse did? No. Simply a comparison, 85.6 is less than 87.9. All right, 21. Carlos finds the absolute value of negative 5 and 3/10 and then finds the opposite of his answer. Jason finds the opposite of negative 5 and 3/10 and then finds the absolute value of his answer. Whose final value is greater? All right, so let's see. Carlos finds the absolute value of negative 5 and 3/10 and then finds the opposite. So the absolute value of negative 5 and 3/10 is 5 and 3/10. Its opposite then would be negative 5.3. Jason finds the opposite of negative 5.3, which is of negative 5.3, which is 5.3, and then he finds the absolute value. So the absolute value of 5.3 is 5.3. So Jason's value is greater. All right. Page 58. Okay, explain the error. Two students are playing a math game. The object of the game is to make the least possible number by arranging given digits inside the absolute value bars on a card. In the first round, each player will use the digits 3, 5, and 7. One student arranges the numbers on the card as shown. What was this student's mistake? So if you take the absolute value of negative 75.3, the answer is 75.3. So that's actually the largest value. Okay, so to get the least value, it should be negative 35.7. Of negative 35.7, which would have given him the smallest number. What's the least possible number on the card can show? Negative. Absolute value of negative 35.7. All right, 23. If you plot the point negative 8 and 85 hundredths on a number line, would you place it to the left or right of negative 8 and 8/10? Okay, so if we just look at negative 8 and 8/10, we can rewrite that as negative 8 and 80 hundredths, and when we have negative 8 and 85 hundredths. So negative 8 and 85 hundredths is further to the left on the number line. So we would put negative 8 and 80 hundredths to the right of negative 8 and 85 hundredths. So we would place it to the left. All right, make a conjecture. If the absolute value of a negative number is 2 78/100. What is the distance on the number line between the number and its absolute value? The absolute value of a negative number is 2 78/100. What is the distance on the long line between the number and its absolute value? Okay, so basically, if we had a number line and we have 0 here, 1, 2, 3, let's say we put negative 2.78 here. Well, its absolute value would be over here at 2.78. So basically, we just have to add these together. So 2.78 plus 2.78, 5 56/100. Because they're the same distance from 0. So to go from negative 2 78/100 to 2 78/100 is a distance of 5 56/100. Right, 25. The deepest point in the Indian Ocean is the Java Trench, which is 25,344 feet below sea level. Elevations below sea level are represented by negative numbers. So write the elevation of the Java Trench. Negative 25,344 feet. A mile is 5,280 feet. Between which two integers is the elevation in miles? Okay, so it's going to be between 4 and 5. Negative 4 and negative 5. Okay, 5, if I multiply 5,280 by 5, I get 26,400, which would be larger than this. If I multiply it by 4, I get 21,120. So it's in between those two integers, but it would be negative because we're below sea level. So graph the elevation of the Java Trench in miles. Okay, so it would be between negative 4 and negative 5. Okay, 25C. So graph the elevation of the Java Trench in miles. So we see when we multiply by 4, we get 21,000. When we multiply by 5, it was 26,400. So it's going to be closer to negative 5. Okay, so negative 5, or closest to negative 5. All right, 26. The number and its absolute value are equal. If you subtract 2 from the number, the new number and its absolute value are not equal. All right, so for instance, if we said 0, right? If we subtract 2, we'd get negative 2. So the new number, negative 2, and its absolute value, the absolute value of negative 2 is 2. So those two numbers are not equal. So we have to have a number that's greater than or equal to 0, but it has to be less than 2. Because if we said 2 and you subtract 2, we'd get 0. Well, the absolute value of 0 is 0. So they would be equal. So 1 would be a possible number. 1 take away 2 is negative 1. The absolute value of negative 1 is 1, so they're not equal. All right, so that's it for today's lesson. So until our next lesson, I'll see you soon.